Hi everyone, this is Dr. Mike, host of the free iTunes podcast, Psychiatric Secrets Revealed with Dr. Mike, but that's not why I'm here today. This is another Saving Savvy episode, and in this episode, we're going to look at something completely different. Now, some of you may know or remember that I am in the process of converting a just raw cargo van into a camper van. And one of the things that I want to do with that camper van is I want to be able to operate it in unimproved campsite. In other words, sites that don't have amenities like electricity. But I still need electricity because I have LED lights and a little 12-volt refrigerator and I need to charge my cell phone, etc. So what I have done, which is what a lot of people do, is I've installed some solar panels on the roof and a battery bank system in the vehicle. That's called, you call it a house battery or a battery bank, and I'm going to use that to power these things. But when I looked at the numbers, it appears that I have some excess energy. And because of that, I wondered if I could cook with that excess energy. Is it possible to cook with solar powered electricity? Can you have enough of it? And I think you can. So this video is about that. So it's a long video, so you might want to watch it in two pieces. It's for the novice, not for the experienced person. So if you're just thinking about this is a great video to look at. Excuse me for coughing here. And lastly, of course, I'm not an electrician. I'm not a solar expert. I'm learning this stuff, but I saw so much disinformation on the internet, even well-intentioned misinformation, that I thought I would do this to kind of, in my mind, set things a little clearer. So let's take a look at a diagram. So in this diagram, we can see kind of a block setup of what I'm talking about. The two sort of lavendery boxes in there, those represent two 100 amp hour deep cycle AGM batteries. And those batteries when combined in a parallel fashion, in other words, positive to positive, negative to negative, produce 200 amp hours. That's the charge that they have, and at 12 volts, because they're 12-volt batteries in parallel. Now, obviously, that's the power that I'm going to draw on, but I need to be able to replace that power once I use some of that power up. And my main way of doing that is going to be by having 3 100-watt solar panels on my roof. So 300 watts total. Now, of course, I can use other methods like my alternator on my car and shore power, but this is the main method. Well, this is electrical energy, and I need to convert that energy into thermal energy or heat energy to cook with. And we do that all the time at home with our appliances. So if you look at the top little breakout over there, you can see home appliances in orange. Well, home appliances run on 110 volts AC or alternating current, and I unfortunately have 12 volts of DC current. But you can use a gadget called an inverter that will convert one power form to another. Now, this is not done for free, and this inverter will waste some of the energy in things like just heating up its circuitry or running a cooling fan or that sort of stuff. And in fact, anywhere between 5 and 20% of the energy will be wasted in this process. And that's going to depend on the load on the inverter as well as just the efficiency or the design of the inverter. So there are cheap, junky inverters that will just burn up a lot more power than better inverters. So you might be saying to yourself that you don't even want to waste 5% of your energy, and you might be wondering if there are 12-volt systems or 12-volt devices or appliances that can do the same thing. And indeed there are. In fact, there are many different kinds of 12-volt appliances out there, which may on the surface seem like an ideal option. But there are some problems with this too, as many of those devices or those appliances tend to be very small capacity. They tend to be very crude in operation. In other words, they might just be on and off, nothing else. And they tend to heat up very slowly. There are a few that I'm going to recommend that I think are exceptions to the rule. But there's a lot of other ones that you really have to really want them to use them. So for instance, you might really, really want a little 12-volt water kettle. Well, that's fine. I mean, people buy them and they use them all the time. Just expect that it's going to take you probably 20 minutes to boil that water. If you can deal with that, hey, then buy one. So we're talking a lot about these appliances and wasting power it's important to know how much power each appliance uses. So luckily, virtually every appliance will list the amount of power in the form of watts that it's going to use. And so here you can see a picture of a very nice toaster oven that I saw at the store. When I turned it around and took the picture, you can see that this particular appliance, when it's used at its highest level, will consume 1,500 watts of power. Well, what does that really mean? Especially because we're talking about batteries that have amp hours. How do watts and amp hours relate to each other? Well, they relate to each other in a very simple way. So if we take watts, which is that 1,500 number, and we divide it by volts, and remember that our system starts at 12 volts. Even if we, in the top diagram, convert to 120 volts or 110 volts, we still are starting with 12 volts. So if we take that 1,500 watts and divide by 12 volts, we get 125 amps, which is a lot of power that's being used. And what does that mean? Well, it really is 125 amps over 1 hour's time. So that's the concept of amp hours. An amp hour is the amount of current consumed or stored or produced in 1 hour. But we need to know that because we want to get appliances that are efficient and that are going to give us the maximum benefit for the least cost in amp hours. So remember I said we have 200 amp hours battery capacity. Well, we can't use that all for cooking, unfortunately. In fact, we have to leave about 1/2 of that total amp hour supply in our battery and never use it, because if we go and drain the battery past that a lot, we're going to actually shorten the life of our batteries, and they're pretty expensive. So 100 is off the top. We're going to use another 40 for housekeeping tasks, running my little 12-volt refrigerator, running my LED lights, charging my cell phone. And then I'm allocating another 10 amp hours for overhead. This might be wastage from the inverter or just things that I haven't calculated. Now that's going to leave us with 50 amp hours in this particular system that are available for cooking. So let's look at some devices that I would recommend. They're both 12 volt and some are 110 or 120 volt appliances that I would recommend for a system like this. The first one is a lunchbox oven. The one that I tested was made by Road Pro, but Burton makes one and other manufacturers do too. This uses about 12 amp hours 12 amps per hour. The next one is a sort of different idea. They call this the Hot Logic Mini, and I think they refer to it portable oven, but it's really more like a mini slow cooker. And that says that it uses 4 amps per hour, but I actually measured it with an amp meter, and it really only uses 3.6 amps per hour, which is better. I went to the store, actually I went to Walmart, and I picked up a couple of appliances. One appliance that I picked up was a 2-quart crock pot. It only cost it was under $10, like $9.95 or something. And that particular crock pot said that it consumed at its maximum rating 100 watts, which is 8.3 amp hours. However, when I actually tested it with the amp meter, it only used 6 amp hours, so that's better. And that was on high. When I shifted it to low, which is similar to what the Hot Logic Mini would use, it only used about 3 amp hours. Lastly, I purchased a small 6-cup Aroma brand rice cooker. This was about $13. It consumes 300 watts, which is roughly about 25 amp hours. Now that looks like a lot more than the others, but don't forget it's going to cook a little bit faster too. So let's actually look at each one of those devices in some detail in the next little series of videos. Okay, this is our first item. I know it looks a little ridiculous, but it actually works pretty darn well. This is the Road Pro Lunchbox Oven. There's other brands that are very similar. Burton makes one and some other brands too, and I know the Burton one is also pretty good. Now this is not terribly well constructed, but it's not awful either, and it looks like a lunchbox. But what you see inside is something different. you see this chamber, I have a little feather in there for some reason, this chamber that you can actually bake in. This reaches 300 degrees. It uses a standard 12 volt outlet. We already talked about its power usage, and you do not cook in here itself. You will usually put some sort of a pan. These 8-inch loaf pans, these disposable loaf pans, are very popular among people that use these. You could use other things. You could line it with aluminum foil or use a baking bag or whatever else you can think of. But you put your food in here, you close it up, you plug it in, and you cook. Now, as an experiment, I made some chicken thighs in this because that's what we had around. I put the chicken thighs in my little metal loaf pan, seasoned it, plugged it into my GoPro Yeti, or GoPro, my Goal Zero Yeti, and came back 90 minutes later. Now, why 90 minutes? I just figured that would be a good time. But it was the right time because the chicken was really perfect. It was browned, juicy, succulent, really delicious, and fully cooked. All in this little toy-looking device. People bake in these things because you do reach that 300 degrees, so they'll make brownies and cornbread and biscuits and other stuff. You can make pasta in this. There's recipes for that on the internet. You can make stews in it, warm up stuff. It's a very, very, very useful appliance, and a lot of truckers use these too. So if they're using it, you kind of have to figure that it really is practical. So this is the first item that I would recommend, the Road Pro Lunchbox Oven. Again, if you bought a Burton or some other brand, that would be fine. Just also. Here's another item on my top list. Again, something that looks kind of ridiculous, but it's really very useful. This is the Hot Logic Mini, and they market this as a portable oven. It's really more like a collapsible slow cooker. So it is this insulated lunch tote, basically. You open it up, and inside you can get it with these Pyrex dishes, or you can just use whatever dish you want. But the trick is, whatever you're using has to have a flat bottom, because this is the heating element right here, and this heats like a slow cooker. It reaches about 165 degrees, which is what a slow cooker would do on low. And here again, you can cook amazing things in this gadget. Now, the one that I have plugs in with a little plug here. However, this is easily convertible to using it in a 12 volt system by using an inverter, either the one that you have, or you can buy one from them. It's like a little baby inverter, very small, because it only uses about 45 watts, so that's not very much power at all. If you didn't want to buy this inverter, I saw that there were some at Menards, for instance, that were under $20 that would serve the purpose. So a very low powered inverter. You put your food in the container. The container needs to be covered because this is a slow cooker after all, and you place it in here and you come back. So to warm up something, it might take an hour. To cook something from frozen, it might take 2 hours or maybe 3 hours, but again, it's just sipping that electricity, not using very much. And in my little experiment, I found this packet of frozen jasmine rice, stuck it in there directly on the surface here, and came back 2 hours later, and it was defrosted, perfectly cooked, and ready to eat. So you can put frozen dinners in their package right on this platform here, and it's going to cook because it's not going to burn. It only reaches 165 degrees. You could take pizza, put a piece of foil down here, put a slice of pizza on there, and come back to warm up your pizza. And of course, you can warm up soups and everything else that you can imagine in any kind of a container. So an item that doesn't look like it would make a lot of sense, but it does make a lot of sense. I think you see a lot of people talking about this particular item, using it in a variety of ways. And again, although mine has the AC connector, you can get one if you want one that is specific for 12 volt. They do sell that too. Not necessary. I thought that the AC one would be a little more handy because I can always plug it into my inverter and at the same time use it in places like hotels if I chose to do that. So that's the Hot Logic Mini, another recommended 12 volt / AC device. And there's Mercury the cat meowing. All right, here we have a standard crock pot, but it's a little bit different. It plugs in, of course. It's different because it's very small. So this crock pot is 2 quarts. I also saw, I bought this one at Walmart. It was only, I think, $9.95, so under $10 for a real crock pot. Menards had a crock pot from Procter Silas that was 1.5 quarts, used slightly less energy than this one did, but this barely sips the energy. and that was fine too. But the nice thing about this is that it's so cheap, and it's going to operate just like your standard crock pot. So you don't have the big flat bottom because you've got this more cylindrical shape, so you're not going to be able to put TV dinners and such on the bottom of the container, but you can do everything that you could do in a crock pot. Now this does have some advantages to the Hot Logic Mini. Notably, it has a high setting. So the Hot Logic Mini basically is a collapsible crock pot or slow cooker that works on low only. But there's times that you want to speed things up. Maybe stuff is not cooking enough, or it's not getting soft enough, or you just need to eat a little bit quicker. You can always switch this on high, which is not an option that you have with the Mini. This also will run off of a very small inverter, so no problem there. However, it does have some drawbacks. The main drawback is that it's a little bit bigger and bulkier and probably a little bit harder to pack than the Mini would be. That's probably the main one. But if you're looking to get into cooking with electricity, with using your solar panels, this is an excellent choice because the investment is so low, $10, that you really can't go wrong. And even if you don't use it, you could always use it at home for dip or something like that. Okay, this is the last general recommendation item. This is a small rice cooker. This one happens to be an Aroma 6-cup rice cooker. The reason we're going with a smaller rice cooker is because they use less energy. So this is a 300-watt rice cooker, and that might seem like a lot, but it does fit into the scheme of things because it generally is going to cook faster because it heats up faster. And so in this example, I actually made some from scratch macaroni and cheese using the stuff that we had around the house. Now, unfortunately, the noodles that I had were these bow tie noodles, and they take quite a while to cook. But even so, the total cook time from start to finish was about 25 minutes, and I had enough for 2 meals. So they're great gadgets. There's a guy on YouTube, his channel is called Living in a Van, and his name is Denoy. I think it's Denoy, I hope I pronounced that right. And he is always using a rice cooker to make just about anything you can imagine using an inverter. So of course you'd have to have a little bit bigger inverter, but 300-watt inverter is certainly not a big deal. Now you want to check the wattage on the device because I saw a similar rice cooker at Menards. I bought this one at Walmart for $13. I saw a similar one, but a different brand at Menards for about the same price, but it was 400 watts. Now, you can certainly work that into your energy budget, and it's probably not going to make that big of a difference. But if you can get something that's a little lower wattage, why not do it? Well, you might wonder if you could use a microwave with this kind of power system. Well, you can, with a lot of caveats. So let's take a look at microwaves and what you could do with a microwave using a solar system. So most microwaves nowadays are about 1100 watts. Now that's the output power of the microwave. They actually use 16 to 1700 watts to produce that output power. The good news is that you can buy small little microwaves that are designed for light duty use. A lot of times kids will use these in their dorm rooms because it won't tax the fragile circuitry in some of those older buildings. These are often 700 watts. And that means that they consume roughly about 1,000 watts. Now, you're going to have to check the back of your microwave to see what it does. Every one is different. The one that I bought my daughter recently for college used about 1,000 watts input. So if we look at that, 1,000 watts divided by 12 volts is 83 amps, which is way beyond our 50 amp hour limit. But with a little simple math, we can figure out that to stay within that 50 amp hour limit, it's going to be about 36 minutes of runtime. So we can operate our microwave for 36 minutes before we consume all 50 amp hours. Well, can you survive for a day on that? Well, you can if you're very conservative. So for breakfast in this example, we're going to have some scrambled eggs scrambled in the microwave, and we're going to heat up some water for some instant coffee or maybe tea. That's 5 minutes and 5 minutes each. For lunch, we're going to have a sandwich and a can of soup. Let's say that's going to take about 5 minutes to heat that up. And for dinner, we're going to have a nice big salad and a Stouffer's frozen lasagna. Now, the lasagna package says it takes about 12 minutes, but don't forget, that's at a 1,000 or 1,100 watt microwave. I'm estimating, because of this power of this microwave is lower, that it's going to be about 18 minutes, which leaves us 3 minutes for maybe a fudge factor. But wait, there's more. First of all, you need to know that you're going to need a really big inverter to operate this microwave, even if it's only consuming 700, or even if it's only consuming 1,000 watts. I would also recommend a pure sine wave inverter, which is the most expensive kind, because there's a lot of computer circuitry in there, including timing circuitry, which may not like a modified sine wave inverter, the cheaper ones. So you're going to have to spend more upfront on the inverter, and you're going to have to be conservative. The other thing that I would warn you about is, if you can at all possibly do it, get a microwave with manual controls, because the electronic display is going to burn up 1 or 2 amps every hour just by blinking at you. And you'll have to unplug it and plug it in when you want to use it to save power. And I would also say that you might want to also include an extra battery, so you get another 50 amp hours of power. So now you have a total of 100 amp hours of cooking power for the day. Well, you might wonder if you could use an Insta Pot. Insta Pots are basically electronic pressure cookers. They're very popular. A lot of other manufacturers make electronic pressure cookers, which pretty much do the same thing, but everyone knows about the Insta Pot. Well, the original Insta Pot uses about, for the 6-quart model, about 1,000 watts, which is pretty pricey. But they do have a little one called the Insta Pot Mini, which is only 3 quarts and uses about 700 watts total. So let's take a look at that one. So that is going to be 700 watts divided by 12, which is 58 amps in an hour. So again, we're kind of over our limit, but Instapots are kind of weird. They do not consume 100% of their power all of the time. In fact, the way that they operate is very different if you're not familiar with pressure cookers than you may think. So if a recipe says, for instance, potatoes take 15 minutes, that is 15 minutes after the pressure cooker reaches pressure. So it's 15 minutes plus that time. It's that reaching pressure time that uses the most energy, because that's when the Instant Pot is heating to its maximum capacity to produce steam. How long does it take to reach pressure? Well, the minimum amount of fluid that you should use in an Instant Pot is about 1 cup of fluid. So I took a 3-quart Instant Pot, put 1 cup of room temperature water in it, and it took about 6 minutes to reach pressure. Now remember, if you have 2 cups, 3 cups, 4 cups, or whatever, it's going to take much longer for it to reach pressure. So if you're making something like soup, expect that it's going to take a bit longer. And obviously different foods have different times, different cooking times. You can see some of those listed below. But once it reaches pressure, things change. It kind of goes into a coast mode, only powering up to full electrical use every once in a while to maintain that pressure. Now, this is a very difficult calculation for us to figure out because it's not straightforward. Luckily, a guy on the YouTube channel, Love Your RV, did this using some of his equipment. And what he did is he took some frozen chicken, put it in an Insta Pot Mini with, of course, some liquid, and he pressurized it and then cooked it for 30 minutes after it reached full pressure. And surprisingly, it only used 16.9 amp hours. So this is definitely possible. This using an Instant Pot is possible in our particular system. However, once again, you're going to need a big inverter, and because the Instant Pot is a computerized device that uses timing, you probably should get a pure sine wave inverter, more expensive. Well, let's look at some tips that might be useful to kind of reduce your cooking times. First thing is, start with room temperature food if possible. I don't want you to poison yourself, but a lot of things don't have to be refrigerated, and things that are frozen can be thawed. Cut your ingredients into small pieces. They'll cook faster. Consider at times using canned vegetables. So when I was a resident with no money, I did have a little crock pot. And one of the meals that I would make is I would take maybe a half a pound to a pound of stew meat, put it in the crock pot, a can of cream of mushroom soup, a package of dry onion soup mix, and then I would just dump a couple of cans of drained vegetables, usually peas and carrots, and then maybe green beans or corn, probably a little can of potatoes, those little round potatoes. And when I would come home that night, I'd have a delicious dinner and probably 2 meals more. So it was a great economical way to stretch my very limited budget. But also, if you use the canned vegetables, you don't really have to worry about having things that are too crunchy. The other thing to consider is to make your main meal at noon. Why is that? Because this is assuming that your main meal is going to take the longest to cook. And if that's the case, you want to have the maximum amount of sun available to recharge those batteries. Naturally, keep things covered unless you need to look at them or turn them over or something. And consider having the same meal for lunch and dinner. So in the example where I cooked chicken in the little lunchbox oven, I had plenty chicken there, and so I could have some hot chicken for lunch, like a regular dinner, and then I would have plenty of chicken for a beautiful, great chicken sandwich for dinner. Now, you may be asking, what am I going to do? Am I going to cook 100% solar? And the answer is probably not. I'm a practical guy, and really, the advantage of cooking solar for me is saving butane, because I'm going to probably use butane instead of propane. But either way, it's the same. So I want to be in a situation where I'm going to use the least amount of butane possible, because it sometimes can be hard to get in isolated communities. It's expensive. And I like the idea of using stuff that's for free. So a way to reduce my butane use is to do some of my cooking using my solar system. And by combining the both, I think I have the best of both worlds, because certain things just work better when you're burning fuel, like making water for a cup of coffee. That's going to be so much faster, or frying a couple eggs, so much faster, making a grilled cheese sandwich, so much faster, making even pancakes, probably so much faster. So I'm going to do combo cooking with the idea of reducing my butane use by half, or maybe even 2/3. Well, now something completely different. We're going to talk about the humble hot plate. Now, this is a tip not so much for the solar users, but for people that just want to save butane fuel. So watch this little video that I did on this. Okay, this is a hot plate. I'm sure you all know that. And this one was about $12 on sale at Walgreens. I saw a different brand for about $12 at Menards. I know Walmart and Target on their websites have similar looking units to this one for about $10. And I'm not recommending this to use in your solar system, because most of these units consume 8 to 1,000 watts. And so they would really deplete your solar system quickly. But if you ever have the opportunity to have shore power, you're in a campground or staying at on a friend's property, these things could really be used very conveniently and quickly, and they can also offset your butane costs if you're doing combination cooking. And I'm recommending this above an induction burner for a couple of reasons. So you're probably thinking I'm an old fossil. In fact, I have an induction stove in my house. I think they're great. I think if you want to go that route, it's great. But these are so cheap, they're a magnitude cheaper than an induction burner. Plus, they are lower wattage. So you think, well, I'm using someone else's power. What difference does that make? Well, it might make a difference if you're on some ancient grid at a county campground, or if you're running, a 40-foot extension cord from your friend's garage. That power drop might make a difference. And so these sip a little bit less power, plus they're going to be able to be used with just about any pan that you have, where induction cooktops need those magnetic pans to work. So because of the cost and the versatility, unless you really want to go the induction route, and the size, I would suggest this. If you use this even twice, it's going to pay for itself. If you use it more than that, you're going to save on your butane fuel and other things. Again, not from the solar system panel, but really if you're able to plug into shore power. So that's one of my bonus tips. Well, there you have it. A lot of information on solar cooking and how to figure out what you need, and to look realistically at what kind of appliances to buy. Remember, you don't need to buy all of those appliances. You just buy one of them and try it out. If you use it a couple times, you probably have paid for itself, and you'll save some money on your butane. Those butane cans here in Illinois are about $3 for a can. The propane cans are about $3.60 a can, and this is at Walmart. I'm sure it's more at other stores. So if you're out in the boondocks someplace, I'm sure it's going to be a lot more than that. So every can that you don't use and that you use your electrical system to cook instead, more money in the bank. Take care, everyone. Again, please subscribe if you like this channel. Please give me a thumbs up if you like this video, and hope to do another video soon. Take care. Bye.